Hi, in this video I am going to show you how to build a decision tree model for data classification. In the previous video we learnt about building a regression a decision tree model for regression problem, but in this video we'll see how we can build a similar model for classifications. Remember, decision tree can well be used for both regression as well as for classifications. All right. So the concept for data classification using decision tree is somewhat different from what we learned in regression. So here is an example of finding out the default and non-default customers on payment, on loan payment. Okay, so we're trying to predict the probability of default on loans. Okay, and let's for instance consider that the blue the blue circles denote the default, and so the blue ones is default and the green ones is non-default. Okay, now a decision tree model for classification will look something like this. So the two factors we have taken into consideration: one is income of the customers and then gender of the customers. Then the first splitting of the data or the partitioning of the data happens through whether the income of the customer is greater than $80,000 or less than $80,000. Now we'll come to know, we'll learn how this this threshold value of 80,000 as the income has been chosen. Okay, and we have also got other factor in place, which is gender, and we have got two, male and female. And what we are doing in regression problem was that we used to take the average of the target variables, but in this case we have got only two categories, right? Blue and greens, or default, non-default. So instead of taking mean, we just need to take the majority count or majority vote. Okay, just go back to the tree, which is this is the at the dead end of the tree you have your decisions, right? Whether it's a default or non-default. How do we get that? Just take a majority count. So here in this case there are four blue points, four so four blue points and three green points, right? So the majority is blue. Hence the decision is that any customer falling in this particular tree is considered to be a blue circle, and blue circle denotes your default. That means here it is default. In this case there are only three blue and two green curves, right? The majority is blue and this is also default. Okay, on the other hand, we have in this particular tree we have got four greens and two blues, so that means it's non-default, right? And here it is again four blues and three greens, so it is default. So that's the way you come to know the the category of a particular customer when we look at this decision tree. Now there are few things to remember here. For any decision tree, whether it's regression or classification, it is built through what is known as a recursive partitioning. That means you partition your data in such a way that you get some sort of a uniformity at the very lower end of the lower end of the split, or lower end of the strata. Okay, so here is the lower end. Okay, and you can see that we assume that there is just one category that belongs to this wing. Okay, and everything else is just an error. So here any customer falling in this particular tree will be considered as default, because that's the majority. So that's the way you do the recursive partitioning, and you take the majority vote and decide which class this particular tree represents. And the way this threshold values, number of split has been taken, the question would arise, how many number of splits are to be there while partitioning your data? For instance, why do we have only two splits? Income greater than 80 and less than equal to 80,000 K. It could be three, it could be four types, right? It could be something like income between 0 to 20, 20 to 60, 60 and above. That could be three splits also. How do we know that how many splits to have? And secondly, how do you know that how deeply we can go down to the data splitting or partitioning of the data. Okay, so these two things will come to know using what is known as classification error rate. So you choose that threshold value, and you choose that many number of your partitions based on what is classification error rate. Okay, that means if the error rate is minimum at certain level of classification, we'll go ahead with that, and that your algorithm will decide how many partitions are to be there, and what is going to be the threshold value, and how many splits are going to be there for each factor. Okay, so that's essentially is what decision tree algorithm will decide to itself. So let's take an example and let's try to understand how we build a model and how we use such a model for data classification. It's a very simple technique rather compared to other machine learning algorithms, and it is also one of the starting point of learning more complicated tree algorithms like your boosting, bagging, random forest, and so on. So it's important to understand the theory and the basic applications, and we'll just see how we can build such a model using trees. So we will take a data set and we'll sort of run through some of the R codes to understand how we can build a model. So I'll take the library ISLR and the library tree. So I'll load these two libraries because in ISLR we've got the data, and the tree library will be used to sort of build the decision tree model. So all right, so now we have loaded the library. So we'll use the dataset called car seats, okay, and we'll attach it so that we can use it later on. So what is there in car seats? Okay, so let's see first. So names, okay. So we've got data for sales of the car seats, okay, and there are different factors which is affecting the sales of car. Now sales of car is essentially a continuous variable. We'll make that a binary one because we're trying to learn here the classification. So we need to have a binary target variable. So these are the the variables in place, and let's see the data here. So here is the data. You can see sales is a continuous variable. We got to make it a categorical one. And we have got how many? 3, 5, 8, 11 of them. So 11 of them are the 10 of them rather. 10 of them are the explanatory variables, potential explanatory variable. We'll see how many of them we can actually use. Okay. So given that the target variable for us, which is sales, is continuous, we just need to make it categorical, okay, or a binary to be very particular. So if the sales is less than equal to 8, then we said we categorize that as no, else it is yes. So that's the criteria of making a continuous variable into categorical. You can of course use any threshold because this is just a data classification, and I've just taken it as 8. You can use 9, 10, depending on what the requirement is. Okay, that's done. Once that is done, we need to go ahead with classifying our data into training and test sample, and this is very important in any model. So we'll use sample function as part of using splitting data into training and test samples. So there are 250, I guess there are 400. Let me see. So there are 400 observations and 12 variables. So I'm going to take 250 in the training set and rest 150 in the test set. Okay. Now I'll use sample function to get the training. So I'm using 250 as the training set. The next thing I'll do is I'll subset the test data from the car seats. So whatever data is not part of training is something that is going to be part of the test data. So we'll use the test data for model validation purpose. We'll also use a test for target, because remember, for target you will not have a target in the test data, right? Because that target cannot be used. We need to predict the target, right? So for validation purpose, for sort of checking the accuracy of your prediction, you need to separately have the target variable for test data. So that's why we have used this variable high plus high dot test equal to it's just subsetting the target variable from the the main data set. Okay, so let's do that. Okay, and if you see what's there in I dot test, we have only a yes and no. Okay, we'll use that for comparison purpose. Okay, then we'll fit the decision tree model. So we'll use function tree, which is going to give us the decision tree. So we'll save the result in a variable called fit. We can use any variable that we used to use. I've just given it a name called fit. Target variable is high. It has taken two values, yes and no. That means cells is high or cells is no. That's essentially. So we're trying to predict whether cell of car seats is going to be higher or lower. That essentially is the motivation behind building this model. The explanatory variables, I'm going to use all the variables in the data set except cells, because we have we have created our target variable from cells, so we cannot use that as explanatory variable. Otherwise there will be a perfect classification. Okay, and perfect classification is something that you do not want to have, because that will never going to be there in future data, right? So that will sort of overfit your model. So remove the cells variables from this data, because that's the variable we have used to come up with the target variable. So apart from this, with this variable cells, we're going to use all other variables as explanatory variables. And then the data is car seats, and we're subsetting it only for training. So let's run this. So that's how you have now the baseline decision tree model. It's probably not the best model, we'll see, and we can tweak the model, or we can fine tune the model in order to make it better. Okay, so let's try to understand what's there in the so how good is the model? Okay, let's see. So you can see that the target variable is high, and how many variables have been used for the decision tree model? So it uses the most optimal variables. Okay, some of the variables which are not very useful for the model, they get dropped. Okay, so we have 7 variables in place which have been used in the model for data partitioning. And how many terminal nodes are there? Terminal nodes are nothing but the end nodes. Okay, so previously I showed you the decision tree. That's where we have the at the back end, at the end of the tree. So the end nodes are nothing but terminal nodes. Residual mean deviance. So this is nothing but similar to what we have seen in regression models, where we have mean square error, root mean square error, something similar, but in this case it is a classification. So a mean square error will not be appropriate. So this is more of misclassification error. So how many times we have got it wrong. Okay, so there is a misclassification error rate specific to classification, that's more useful. And we are seeing that there are 223 misclassification in the training data from 250 observations. So out of 250 observations, 227 observations have been classified correctly, except for the 23 observations. So the error rate is 9%, which seems to be good. But then we cannot trust the training data itself. We just need to look at what is the classification error rate in the test data. Only when we will trust the model to be good or bad. Okay. So let's plot it, because the best part of decision tree is you can actually visualize it correctly, and you can explain the visual plot to even layman, somebody who is not familiar with machine learning. So let's run this code. So the syntax for plotting data is just use plot and text functions. I've just given it to you. It looks clumsy. You can use better visualization libraries to make it better. There are so many there are 25 terminal nodes. That's why it is looking so clumsy. It's probably not the optimal one. We need to get down to smaller number of terminal nodes. Okay, so the first variables is based on okay, something like this. This is okay, and then we have price. So price is an important factor for the cells. Yeah. Now remember one thing, decision tree is not just used for prediction of target variable or prediction of your data or partitioning of data. It is also used for knowing the segmentation in your data. Many a times you will be building models in machine learning for which you need different segments. So decision tree may not be your final model, but you start with the decision tree just to understand how well or how should you go ahead with segmenting your data into different subsegments and build separate model for each segment. Okay, so decision tree is also used to understand the different segments that ideally should have in your data. So that's another use of decision tree. The next thing that we'll do is predict our target variable for test data. Remember, in test data we need to predict using the model statistics. So we have got the model statistics. So what are the model statistics? 25 decisions nodes. So based on this model statistics, we'll see how good the model is performing in the test data. So that is to be some kind of a model validation. So we'll use the predict function and we'll provide the test statistics, which is fit. That's where we have saved our test statistics, right? And then we'll provide the data test data, and the type is class. Type is class because this is a classification decision tree. It's not a regression decision tree. So once we have that, we'll have the confusion matrix just to see the accuracy. Okay, what is the percentage of correct classification? Remember, for test data, we already have the target variable in place. So we'll try to cross tabulate the target variable with respect to the predicted variable. Now the predicted variable for test data is pred. Now when you tabulate it, so we tabulate toss tabulated pred, which is the predicted value, and the actual value. Okay, and we see okay, so what is the correct classifications? The correct class is the actual is no and predicted is no is 59 times, actual is yes and predicted is yes is 18 times. Okay, and there is a very bad, it's a doing very bad in the test data. Okay, although it is doing somewhat okay in training data, but it's doing pretty bad in the test data. So what is the error rate in this case? Okay, let's see. So 59, that's correct classification for no, and then 80, which is for yes, and then the total is 150. That means while it is doing really good job of 90 to 91% correct classification of training data, it is doing a very bad job in the test data. There is only 51% correct classification. So the model is doing very bad. It's an overfit model, and it is doing extremely bad in the test data. So something needs to be done. Okay, maybe the model we have fit is overfitting. So one of the reasons why it could be overfitting, because we have just such a big tree. Okay, such a very long tree. It probably needs more optimization. Okay, so how do we do that? So we optimize tree by what is known as pruning the tree, and we have also learned this concept in the previous video on decision tree on regression. Pruning of tree is nothing but cutting down on some of these subtrees, because that's not optimal. So just coming up with the number of terminal nodes which optimizes the error rate data. Okay, so we'll use the cross validation for that. So how do we do that? So we'll first cross validate the model fit, which is in the training data, and we'll see what is the correct number of trees or correct number of terminal nodes that we want the model to have, so that the correct classification will be better or at least improve. Okay, so we use the syntax cv.tree, which is a function, and we provide the test statistic which is there in fit, and we also use what is fun equal to prune.misclass. So that's another. So this is what the syntax for cross validating. And let's see what's there in cv.tree. cv.tree is the variable where we have saved the cross. Okay, let's summarize it. Okay, when you print it, you find the deviance. So deviance is more of a misclassification in this case. So we have got the optimal number of trees in this case. Okay, so look at the deviance and see how many number of misclassification is there in this. That goes 1, 2, 3, 4, 5, 6, 7, 8, 9. That means there are 9 terminal nodes that should be there in the decision tree. But in the training data we had 25. That's much bigger. That's why it was overfitting. So we should essentially have 9 instead of 25. Okay. So now let's prune the model and prune it in such a way that it is optimal in nature. Now we know from cross validation that the optimal number of terminal nodes should be 9, so not be 25. So we use the prune.misclass function and we prune the decision tree model. So decision tree statistics is there in fit, the variable fit, and then we use best equal to 9. That means it says that we are trying to optimize it by cutting down on the, or by lowering the number of terminal nodes, and you have brought down it to 9 from 25. Okay, so let's run this, and okay, let's summarize this. Spoon.fit. Okay, now you remember what was the error percentage last time when we did it with the test data? It was 49% because the correct classification was only 51%. So error rate is 49%. Now it has improved drastically. Okay, it has improved drastically. We have just have 16% of error classification, which is fairly okay because there is 84% of correct classification, right? So the model has improved. So pruning is very important because it optimizes the decision tree model. We can also plot it using plot and text, and I'm sure this will look much better because the number of terminal nodes has gone down. Alright, you can also tabulate it. Okay, you can use the actual values and the predicted value to tabulate it to see the confusion matrix. So we'll use this syntax. You can use tabulate, and okay, let us do that. Well, you already know the error rate, so we don't need to do that again. Okay, fine. So you can use the table function to build the decision tree, and the error rate is 16%. So that's how you can build a classification decision tree model. Remember one thing, that what is important here is optimizing the decision tree level. So how many number of terminal nodes that you will have in the model will decide how efficient is going to be your decision tree model. Second thing to remember here is that it's not just predicting your target variable for which you can use decision tree. You can also use your decision tree to understand the data classification in your data classification, and that will help you segment your model. And you can be other models like logistic regression or other models like support vector machines, or any of these neural network models. Why it is so important is because many a times you will need to build several models for different segments. So the segmentation could be done through a very simple cross tabulation of your target variables, but it can also be done using a little more sophisticated technique like decision tree. So that's another use of decision tree. Thank you.